students, welcome to lecture series of Mathematics 1. I am Hitesh Manglani, Assistant Professor at LJ Institute of Engineering and Technology. So today we will discuss topic that is absolute and conditional convergence and power series of chapter sequence and series. So first of all, we will discuss about absolutely and conditionally convergent. So the series sigma n equal to 1 to infinite un is called absolutely convergent if the series sigma n equal to 1 to infinite modulus of un is convergent. And the series sigma n equal to 1 to infinite un is called conditionally convergent if the series sigma n equal to 1 to infinite un is convergent, but sigma n equal to 1 to infinite modulus of un is divergent. Now we will discuss theorem, that is, if the series sigma un is absolutely convergent series, then sigma un is convergent. Note that if convergent series is a positive term series, then it is absolutely convergent. Now we will discuss example related to this. Determine absolute or conditional convergence of the series, that is sigma n equal to 1 to infinite minus 1 raised to n into n square divided by n cube plus 1. So here un is equal to minus 1 raised to n into n square divided by n cube plus 1. So first of all we will find out modulus of un. Therefore modulus of un is equal to n square divided by n cube plus 1. Because if we take modulus of minus 1 raised to n, then it is 1. Now here we will take n cube common from denominator. So it will be n square divided by n cube into 1 plus 1 divided by n cube. So this is equal to 1 divided by n into 1 plus 1 divided by n cube. Because here n square divided by n cube, so it will be n. Now let Vn is equal to 1 divided by n. Now we will find out limit n tends to infinite modulus of un divided by Vn. So that is equal to limit n tends to infinite 1 divided by 1 plus 1 divided by n cube. Now here we will replace n by infinite. So here 1 upon infinite will be 0. So here 1 divided by 1 plus 0. So it will be 1, and which is finite and non-zero. But sigma n equal to 1 to infinite Vn is equal to sigma n equal to 1 to infinite. What is Vn? It is 1 divided by n, which is a p series with p equal to 1. Therefore sigma n equal to 1 to infinite Vn is divergent. Therefore sigma n equal to 1 to infinite modulus of un is also divergent by limit comparison test. So the given series is not absolutely convergent, because as we have discussed earlier, if sigma mod un is divergent, then that series is not absolutely convergent. Now for conditional convergence, we will find out modulus of un minus modulus of un plus 1, that is equal to n square divided by n cube plus 1 minus un plus 1 will be here replacing n by n plus 1, so it will be n plus 1 raised to 2 divided by n plus 1 raised to 3 plus 1. So here it will be n square divided by n cube plus 1 minus, here using the identity a plus b whole square will be a square plus 2ab plus b square. So it will be n square plus 2n plus 1 whole divided by, here we will use the identity that is a plus b raised to 3 is equal to a cube plus 3a square b plus 3ab square plus b cube. So it will be n cube plus 3n square plus 3n plus 1 plus 1, so it will be plus 2. Now if we simplify this, then it will be n square into n cube plus 3n square plus 3n plus 2 minus n cube plus 1 into n square plus 2n plus 1 whole divided by n cube plus 3n square plus 3n plus 2 into n cube plus 1. So if we simplify this, then here it will be n raised to 4 plus 2n cube plus n square minus 2n minus 1 whole divided by n cube plus 3n square plus 3n plus 2 into n cube plus 1. So here we will take n square common from these two terms and we will take minus 1 common from these two terms. So it will be n raised to 4 plus n square into 2n plus 1, and here we will take minus 1 common, so it will be minus 1 into 2n plus 1 whole divided by n cube plus 3n square plus 3n plus 2 into n cube plus 1. Now we will take 2n plus 1 common from these two, so it will be n raised to 4 plus 2n plus 1 into n square minus 1 whole divided by n cube plus 3n square plus 3n plus 2 into n cube plus 1. So this is greater than 0. Therefore, modulus of un is greater than modulus of un plus 1. Now we will find out second condition, that is limit n tends to infinite modulus of un. So this is equal to limit n tends to infinite. What is modulus of un? It is n square divided by n cube plus 1. So here we will take n cube common from denominator. So it will be n square divided by n cube into 1 plus 1 divided by n cube. So if we simplify this, then it will be 1 divided by n into 1 plus 1 divided by n cube. Now we will replace n by infinite. So here 1 upon infinite will be 0. So here it will be 1 plus 0. So it will be 1 into infinite. So here it will be infinite, and 1 upon infinite will be 0. So this is equal to 0. By Leibniz test, series sigma n equal to 1 to infinite, un is convergent. So the series sigma n equal to 1 to infinite, un is convergent. But sigma n equal to 1 to infinite, modulus of un is divergent. Hence the series is conditionally convergent. Because if sigma un is convergent and sigma mod un is divergent, then we can say that series converges conditionally. Therefore, series is conditionally convergent. Now we will discuss next example, that is determine whether the series sigma n equal to 1 to infinite cos n divided by n square is equal to cos 1 divided by 1 square plus cos 2 divided by 2 square plus cos 3 divided by 3 square plus so on is convergent or divergent. Here un is equal to cos n divided by n square. Now we will find out modulus of un. Therefore, modulus of un is equal to modulus of cos n divided by n square, and this is less or equal to 1 divided by n square. Therefore, we can say that modulus of un is less or equal to vn. Here sigma vn is equal to sigma 1 upon n square, which is a p series with p equal to 2 and which is greater than 1. So sigma vn is convergent, and therefore the series sigma modulus of un is also convergent by direct comparison test. Therefore, the given series sigma un is absolutely convergent because here sigma mod un is convergent. So if sigma mod un is convergent, then we can say that sigma un is absolutely convergent. Now we will discuss power series. So a series of the form sigma n equal to 0 to infinite an into x minus a raised to n is equal to a0 plus a1 into x minus a plus a2 into x minus a raised to 2 plus so on is called a power series in powers of x minus a, or a power series about the point x equal to a. Here x is a variable and ans are constants called coefficients of the series. For example, sigma n equal to 0 to infinite x raised to n divided by n factorial is equal to 1 plus x raised to 1 divided by 1 factorial plus x raised to 2 divided by 2 factorial plus x raised to 3 divided by 3 factorial plus so on is a power series in powers of x. Now we will discuss example related to this. Test the convergence of the series 1 divided by 1 into 2 into 3 plus x divided by 4 into 5 into 6 plus x square divided by 7 into 8 into 9 plus so on, where x greater than 0. So here un is equal to x raised to n minus 1 whole divided by 3n minus 2 into 3n minus 1 into 3n. Because here if we put n is equal to 1 in un, so here it will be x raised to 1 minus 1, so it will be x raised to 0 divided by 1 into 2 into 3. So we will get this first term. Now here if we put n is equal to 2 in un, so here it will be x raised to 2 minus 1. So it will be x raised to 1 divided by 4 into 5 into 6. So we will get the second term. Same way if we put n is equal to 3 in this un, so it will be x raised to 3 minus 1. So it will be x raised to 2 whole divided by 7 into 8 into 9, which is third term. So this is un. Now we will find out un plus 1. So for that we will replace n by n plus 1 in un. So it will be x raised to n whole divided by 3n plus 1 into 3n plus 2 into 3n plus 3. Now we will find out ratio of these two, that is un plus 1 divided by un. So this is equal to x raised to n divided by 3n plus 1 into 3n plus 2 into 3n plus 3 into 3n minus 2 into 3n minus 1 into 3n whole divided by x raised to n minus 1. So here we will take n common from this bracket, same way we will take n common from this bracket. So it will be 3 minus 2 divided by n into 3 minus 1 divided by n into 3 into n cube. Same way here we will take n common from these three brackets. So it will be 3 plus 1 divided by n into 3 plus 2 divided by n into 3 plus 3 divided by n, and here n cube divided by n cube will be cancelled out. So here x raised to n minus 1 can be written as x raised to n into x raised to minus 1. So x raised to n cancel out. So 1 divided by x raised to minus 1 will be x. So this is un plus 1 divided by un. Now we will find out limit n tends to infinite un plus 1 divided by un. So it will be limit n tends to infinite 3 minus 2 divided by n into 3 minus 1 divided by n into 3 whole divided by 3 plus 1 divided by n into 3 plus 2 divided by n into 3 plus 3 divided by n into x. So here we will replace n by infinite. So here 2 divided by infinite will be 0. Same way 1 divided by infinite will be 0. Same way here 1 divided by infinite will be 0. Same way 2 divided by infinite will be 0. And same way here 3 divided by infinite will be 0. So here it will be 3 into 3 into 3, that is 27, divided by 3 into 3 into 3, that is 27. So 27 divided by 27, so it will be cancelled out. So into x, so that is equal to x. Now by D'Alembert's ratio test, the given series is convergent if 0 less than x less than 1, and it is divergent if x greater than 1, and the test fails if x equal to 1. So here we will have to check for x equal to 1, because if x equal to 1 then ratio test fails. So if we put x equal to 1 in un, then it will be 1 divided by 3n minus 2 into 3n minus 1 into 3n. Now here we will take n common from this bracket, same way we will take n common from this bracket. Therefore un is equal to 1 divided by n cube into 3 minus 2 divided by n into 3 minus 1 divided by n into 3. Now let Vn is equal to 1 divided by n cube. Therefore limit n tends to infinite un divided by Vn is equal to limit n tends to infinite 1 divided by 3 minus 2 divided by n into 3 minus 1 divided by n into 3. So here we will replace n by infinite. So here 2 by infinite will be 0. Same way 1 by infinite will be 0. So here it will be 1 divided by 3 into 3 into 3. So it will be 27. So it will be 1 divided by 27, which is finite and non-zero. Now sigma Vn is equal to sigma 1 divided by n cube, which is a p series with p equal to 3. Therefore the series sigma 1 divided by n cube is convergent. Therefore by limit comparison test, sigma un is also convergent for x equal to 1. Now we will summarize this. Hence the series is convergent for 0 less than x less or equal to 1, because here sigma un is convergent for x equal to 1. Therefore here it will be 0 less than x less or equal to 1, because series is convergent for x equal to 1, and divergent for x greater than 1. Now we will discuss next example, that is test the convergence of the series sigma n equal to 0 to infinite n plus 1 divided by n plus 2 whole raised to n into x raised to n, where x greater than 0. So here un is equal to n plus 1 divided by n plus 2 whole raised to n into x raised to n. Here we will apply root test. So for that we will find out un raised to 1 divided by n. Therefore un raised to 1 divided by n is equal to n plus 1 divided by n plus 2 into x, because here if we find out un raised to 1 by n, so here it will be n raised to 1 by n, so it will be n into 1 by n, so n cancel out. Same way here x raised to n raised to 1 by n, so it will be x raised to n into 1 by n, so n cancel out. Therefore un raised to 1 divided by n is equal to n plus 1 divided by n plus 2 into x. Therefore limit n tends to infinite un raised to 1 divided by n is equal to limit n tends to infinite. Now here we will take n common from numerator as well as from denominator. So it will be n into 1 plus 1 divided by n whole divided by n into 1 plus 2 divided by n into x. So here n cancel out. Now we will replace n by infinite. So 1 upon infinite will be 0. Same way here 2 upon infinite will be 0. So this will be 1 divided by 1. So which is 1 into x. So this is x. Now by root test, the series is convergent for x less than 1 and divergent for x greater than 1, and the test fails if x equal to 1. Therefore we will discuss for x equal to 1, because for x equal to 1 root test fails. So put x equal to 1 in un, then un is equal to n plus 1 whole divided by n plus 2 raised to n. Now we will find out limit n tends to infinite un, so that is equal to limit n tends to infinite. So here we will take n common from numerator as well as from denominator. So it will be n raised to n into 1 plus 1 divided by n raised to n whole divided by n raised to n into 1 plus 2 divided by n whole raised to n. So here n raised to n cancel out, and we know that limit n tends to infinite 1 plus 1 divided by n whole raised to n is e. So this can be written as e, and here we will write down this as limit n tends to infinite 1 plus 2 divided by n raised to n divided by 2 into 2. So this will be e square. So here e divided by e square, so it will be 1 divided by e, which is not equal to 0. Hence the series is divergent for x equal to 1 by nth term divergence test. Hence we can say that the series is convergent for 0 less than x less than 1, because here for x equal to 1 series is divergent. So here we will write down 0 less than x less than 1, and it is divergent for x greater than equal to 1, because for x equal to 1 series is divergent. So in today's lecture we have discussed about absolute convergence, conditional convergence and power series. Thank you for watching this lecture. I will see you in the next lecture.